Good day, panel of judges. My name is Okaiyeto. I'm here to present a paper titled Development and Performance Evaluation of a Manually Operated Vegetable Slicer. Introduction. Vegetables of all kinds are a very important part of our daily diet. They are very rich sources of important minerals and vitamins. However, it is important for vegetable products to undergo slicing operation prior to their preservation, or even if it is to be used directly. There are different reasons for slicing vegetable, one of which is drying purpose. The materials to be dried needed to be sliced first into smaller units. This is to ease the dehydration process. Commonly sliced vegetables are tomatoes, okra, pepper, spinach, lettuce, potato, and cassava. Slicing operation involves different methods by which vegetables in bulk are reduced into a predetermined width and length of cut. Traditionally, manual labor is employed using a knife to reduce the vegetable product into smaller sizes. This method of slicing is time consuming and also poses a risk to the operator from knife cuts. However, modern slicing methods employ the use of a slicing mechanism suitable for slicing vegetables into desired sizes. This method is faster and highly efficient, but due to the cost and technicalities involved in the operation, modern techniques are out of the reach of the locals. Therefore, the aim of this study were to provide household and small industry with a portable manual slicing machine that will avoid drudgery and also eliminate the challenge of knife cuts or the risk of knife cuts. And the second objective is to evaluate the developed slicing machine. Materials and methods. Design consideration. The following factors were considered in the design in order to achieve the design goals and purposes of construction. And these considerations were availability of the construction material, suitability of the construction material, low cost of the construction material, maintainability, and ease of operation. Material selection. Materials of various components of the vegetable slicer were selected based on their strength, flexibility, availability, resistance to heat, and also resistance to corrosion. Very important because vegetables are edibles, so any corroded surface will pose a risk to the health of any individual that consumes such vegetables. Mild steel carbon sheet of gauge 18 was selected and used in the construction of the support surface. Galvanized metal sheets were used in the fabrication of the feeding chamber. Blade plates and angle iron were used in making the support frame. Design calculation. The following formulas were used in designing of this slicer. First, the blade weight was designed using the formula W is equal to V multiplied by rho, where V is the volume of the blade, rho is the density of the galvanized sheet. Bending stress was also calculated. Sigma B is the bending stress in Newton per millimeter square. MB is the bending moment in Newton millimeter. B is the width of the handle in millimeter, while D is the thickness of the handle. Velocity was also calculated using the formula V is equal to U plus AT, where V is the velocity of the reciprocating blade U is the initial velocity of the blade, which is usually 0, and T is time taken to slice the vegetable in seconds. But since the initial velocity is 0, therefore V is equal to A. This implies that A is equal to D all over S. D is the distance traveled by the reciprocating bar, while S is the time in seconds. This figure shows the asymmetric view of the slicer. The machine consists of a frame, a handle, reciprocating bar, stationary blade, and a mobile blade plate, as seen in this figure. The handle has two links joined together by a round metal of about 36 mm diameter, which the operator will hold and bring down to effect the slicing operation. Performance indicator. There are two performance indicators employed in evaluating this slicer. They are the output capacity, denoted by C, and slicing efficiency, denoted by SE. C is the output capacity, QS is the weight of the vegetable collected in a unit slicing time, which is in kg. T is the slicing time in hour. SE is the slicing efficiency. W1 is the weight of the sliced material in kilogram. W2 is the weight of the unsliced material, also in kilogram, while W is the initial weight of the material to be sliced. Result and discussion. Table 1 shows the data obtained for slicing of carrot. Table 2 shows the data obtained for slicing of tomatoes, while Table 3 shows the data obtained in slicing okra. Now, results obtained from Table 1, 2, and 3 indicated that carrot had a highest slicing efficiency of 61.59%, tomato had the highest slicing efficiency of 61.59%, and less time was taken to slice tomato because the tomatoes were at very high moisture content, hence making it easy for the tomatoes to slice. Okra slicing has a highest efficiency of 60.21%. This is as a result of some of the okra pods that were discarded due to their relative hardness to slice. However, in all cases, time required for slicing depends on loading speed of the vegetables into the machine, the moisture content of the vegetables, and the sharpness of the blade. The mean thickness of the cut slices obtained was 13 mm. From Table 1, carrot had a highest throughput capacity of 27.96 kg per hour, while from Table 2, tomato had a highest throughput capacity of 75.25 kg per hour, and from Table 3, okra had a highest throughput capacity of 68.22%. Now, tomato had the highest throughput capacity because it was relatively faster and easier to slice tomato due to its succulent nature when compared to okra and carrot. In turn, carrot was the hardest to slice because of its strength, and that is why it had the least throughput capacity. Conclusion. In conclusion, a vegetable slicer was designed, constructed, and assembled using locally available material based on the detailed design and performance evaluation of the developed machine. Slicing efficiencies determined from evaluation results were 61.7%, 61.59%, and 60.21% for carrot, tomato, and okra respectively. Average output capacity of 27.96 kg per hour, 75.25 kg per hour, and 68.22 kg per hour were obtained for carrot, tomato, and okra respectively. This machine constructed has a great potential of cutting different types of vegetables and may also be used in slicing fruits like orange, apple, pineapple, etc. Now, this machine was not fabricated to substitute the already existing slicer, but to supplement or ease the suffering of local farmers and individuals in slicing vegetables. Thank you for listening.